I'll now introduce Catarina Mota, founder of Open Materials. Thank you, Catarina.
Thank you. Thank you. Oh, well. May I get started? Here we go. Okay. So, good morning, LCA, and thank you so much to the organizing team for their kind invite. It's quite an honor to be here today. So this year's theme is Life is Better with Linux. And the first thing I must do is tell you that I owe all of you a debt of gratitude. Everyone in this room has made my life better because you make Linux. I mean, Linux itself has made life better for millions of software users and developers. But it has made life better not only but that's not the only way in which it changed the world. When the Linux community made it the success it is today, it also established collaborative open source development of technologies. And in a way, that paved the way for the community I'm a member of, which is the vast network of open source hardware developers, enthusiasts, and advocates. So when I say that you made my life better, it's not just because you make Linux, it's because you make open source. So that's what I would like to talk about today. So to put things in context, I would like to start by telling you a short story of how open source changed my life. So these days I wear a few different hats. I'm an open source advocate, hardware and materials nerd, a farmer in training, and a humanities scholar. So most of my time is split between contributing to and advocating for open source hardware, designing and building houses and related technologies, researching materials, growing food at our farm, and being a social scientist, thinking about what all of this means for society at large. So this is where I am now, but I started out many years ago as a film student. At the time, I was lucky to have had the opportunity to work with World War II 16mm cameras and Steenbeck editing machines, where you manually looped and spliced the film so you could see exactly what you were doing and how the machine worked. So the whole process was completely transparent, and for this reason, most of us developed a special relationship with the machines we used. So this was the first time I became aware of how the characteristics of machines and the relationships we established with them influenced the work we do. So shortly after graduating from college, I began looking for a master's program in film, and at the time I lived in New York City, so NYU's film program seemed like a natural choice. So I went up to the Tisch School of the Arts to obtain more information on the program, got in the elevator, and then something strange happened. So I often get in trouble for being a daydreamer, like I tend to lose track of where I am or what I was doing, but that day this actually worked to my advantage. When the elevator doors opened, I got out not realizing I was on the wrong floor. So I meant to go to the film department, but I had actually gotten off at the Interactive Telecommunications program floor. So this is known as ITP. ITP is a technology master's for people with previous formal training in a variety of areas, from film and arts to writing and dance. There are many such programs now, but at the time they weren't very common. So I went to the reception desk and asked for information about the program, and of course, as soon as they started telling me about it, I realized my mistake. But they were so nice that I didn't have the courage to say, whoops, I'm on the wrong floor. So I decided to just go along with the tour, and then my mind was blown. So everywhere there were these crazy inventions like household appliances like blenders and toasters repurposed to behave like farm animals. There were robotic arms, there were mirrors made of wood and motors. It was quite amazing. But what was truly astonishing was that these things weren't in a gallery or showroom, and they had not come out of Xerox PARC. They had been made by people like me. And suddenly I realized I want to be part of this. And so that's how I ended up going to ITP instead of film school. Now, the next 2 years were life-changing for me. Within 1 semester, I was making motion tracking devices, and within 2 semesters, my friend Kim Murray and I had created a device that tracked and responded to the direction of someone's gaze. So this was in 1998. We already had the web, browsers, digital cameras, but things such as live video streaming or video conferencing still felt very much like black magic. And there were no commercial gaze tracking devices. There were no Wii or Kinect or anything like that. So the fact that 2 filmmakers like us could create devices that didn't yet exist, things that we're only beginning to dream of, made us feel very empowered. The device, of course, was very rudimentary, but this experience made me think that I too could participate in the invention of the future, instead of just being a spectator on the sidelines. So it was at this point that I got my first glimpse of the relationship between the ability to create, to contribute to the shaping of the world, and the way we perceive and exist in that world. Now, the reason all these unusual experiments and devices were being created at ITP was not because the entire school was made up of geniuses. In fact, the fascinating and important thing is that most of us are not geniuses. We were just people, normal people, who for one reason or another had landed in an environment geared for rapid learning and experimental creativity. So at ITP, we were encouraged to take risks, to venture outside our comfort zones, and to push the limits of what we thought we could do. The idea was that anyone can do anything. In this context, failing was not only acceptable, it was encouraged. The faster we failed, the faster we learned. So this created a very safe environment for growth and learning, but it wouldn't have been enough per se. Believing we can do something is just the beginning. We also need to be able to rapidly acquire the knowledge and skills needed to execute on those ideas. So the other important lesson I learned at this time was that information sharing can change everything. At ITP, we weren't so much taught technologies as we were taught strategies to approach and understand technologies. And a lot of this was done through informal knowledge sharing. Professors and students were constantly sharing information and swapping programs and circuit designs. Everything was done out in the open. You could just walk up to someone and say, "Wow, how did you do that?" And they would give you all the details. This was what was then open source software, of course, and later gave rise to open source hardware. We were able to create things because others were willing to share what they knew, and we could build upon their work. So when I graduated, I thought this is how the world worked. You know, people just shared information and collaborated. Of course, I was in for a terrible shock and quickly learned that that's not how most of the world works. So now, fast forward 10 years to 2009. At this time, open source software was firmly established, and open source hardware was expanding. Knowledge sharing and collaborative work were gaining terrain. The first European hackerspaces from the 80s and 90s were inspiring a new generation in the US and soon began popping up all over the world. Groups of open source hardware developers were working hard to bring 3D printers and laser cutters to the average citizens. And at this time, I was lucky to come across a group of Portuguese hackers who had started one of the country's first hackerspaces in the city of Matosinhos. Together, we set up another one in Lisbon. In a matter of months, we were joined by a third one in Coimbra. And within weeks, we were making 3D printers. So this is a RepRap Darwin, an open source 3D printer a group of us built in Madrid in early 2009. As you can see, it was little more than a jumble of wires and tape. It barely worked, to be honest. But for many of us, it was one of the most important things we had ever worked on. In this ugly mess of a machine, we saw the promise of a world in which we could be co-creators, not just consumers. So this was very meaningful to us, despite the lack of practical applications at the time. So suddenly, those things that had changed my life 10 years earlier were no longer the privilege of the few who could attend grad school. They were out there, available to a growing number of people around the planet. And from our little nerd bubble, it felt like the world was changing, and I wanted to know where it could take us. I thought that if access to knowledge and tools had changed the way my friends and I see the world and our role in it, perhaps it was doing the same for many others. Perhaps we're on the edge of a major transformation. So I put on the humanities scholar hat and set out to learn just exactly what that was. Now, the first question, of course, is what exactly is happening? What is changing? At first, it was difficult to discern in a series of apparently unrelated phenomena, but soon a pattern began to emerge, and we could see that what was happening was the democratization of the ability to create hardware and other material goods. In a seminal 2010 article titled "In the Next Industrial Revolution, Atoms Are the New Bits," Chris Anderson captured this idea in one sentence. He wrote, "If the past 10 years have been about discovering post-institutional social models on the web, then the next 10 years will be about applying them to the real world." Meaning, the participatory culture of the internet was beginning to spill into the real world. And this was enabling the emergence of what can be loosely described as DIY hardware. So at first, DIY hardware focused mostly on electronics. Microcontrollers like the Arduino and Raspberry Pi allowed people with no formal training in technology to create their own electronics and led to a wave of creativity. People from all walks of life began making art installations and devices, ranging from the serious and useful to the playful and whimsical. Digital fabrication tools were another very important component of this transformation. Various types of digital fabrication technologies have existed for decades, but until less than 10 years ago, they were still quite expensive and large in size, and therefore accessible mostly to large organizations such as universities and companies. So this began to change with the RepRap project, the first open source 3D printer, which I'm sure many of you are very familiar with. But rather than talk about it, I'd like to just show you a short video about the project.
We print documents and photos from our computers daily. Most of us in the developed world effectively run a home printing press and a home photographic lab, courtesy of this technology. Suppose you could plug a 3D printer into your computer. This 3D printer makes solid, strong plastic goods from designs that you've created yourself or that you have downloaded from the web. You could make lots of useful stuff that, at the moment, you have to buy. In effect, you would be running your own factory alongside your printing press and your photographic lab. There's nothing new about 3D printers. They have been around for almost 30 years, but all the commercial ones are very expensive. They typically cost about 20,000 euros. This is the RepRap 3D printer working. You can make it yourself, and doing that will only cost you around 500 euros. What's more, following the principles of the free software movement, the designs for the RepRap machine are being distributed to everyone free under the GNU General Public License. And here is the really clever bit. Those designs include all the plastic parts for the RepRap machine itself. So, if you have a RepRap machine, you can print a new one for a friend. RepRap was thought up by Adrian Boyer at Bath University.
I started the RepRap printer by a biomimetic analogy. That is to say, an analogy taking an idea in nature and putting it into engineering. The object in nature that I copied was the phenomenon of symbiosis. In particular, if we look at the symbiosis between the insects and the plants, which has been running for 130 million years since the late Jurassic, that is an incredibly successful and stable symbiosis. And we all know how it works. The plants need to pollinate each other, but they can't move, so they make nectar as well as pollen. The insects visit the plant to obtain the nectar, and in doing so transfer the pollen to the other plant. The insects get a meal, the plants get to reproduce, everybody's happy, both species benefit from the relationship. The RepRap printer is intended to be exactly the same, with people taking the role of insects and the printer taking the role of the flowers. Because the RepRap printer doesn't just copy itself, it also makes useful goods. And those goods are the equivalent of the nectar, and that nectar, those goods, rewards the people who assemble the machine, because those people are helping the machine to reproduce in just the same way that the insects help the flowers to reproduce. The RepRap printer works by melting plastic and then building it up into three-dimensional objects which solidify when they cool. It starts with a filament of plastic about 3 millimeters in diameter, rather like a piece of wire. And that filament is fed into a melting head in the machine and then extruded out of a very fine hole. The machine then scribbles with that molten plastic onto a flat plate to make a layer of the object that's to be built. The plate then drops down by a small fraction of a millimeter, and the next layer is scribbled on top of that, and so on until the whole component has been built in 3 dimensions.
Vic Oliver from New Zealand is another member of the team.
I just love the ability to design something, have it made right there on my desktop, and then realise I've done it wrong, correct it, leave the thing printing, come back in the morning, and there it is, perfect and glorious.
There are 16 people in the core RepRap team from all over the world, and many others who help informally. The writing of the software and the documentation is done by this collective, as is the design of the electronics and mechanics. All the software, documentation and designs are published and shared on the web using wikis, blogs and SourceForge. Ed Sells is one of the principal people involved in the mechanical design of RepRap.
One of the key challenges to designing the printer is to design it in such a way that it can make its own parts. For the first version, if we do a simple part count analysis on the design, we find that it can make about 50% of its own parts. As we develop the second version, which is what we're currently working on, we hope to improve this ratio to bring the number of parts that it can make for itself up. We hope to do this by developing new deposition heads so that we can print in new materials and increase the functionality of the printer.
In May 2008, RepRap achieved replication for the first time. This parent machine made a complete set of parts that were then used to build this child machine. The child machine was immediately put to work making grandchild parts. The team are now working on version 2 of the RepRap machine. Version 2 will, of course, be printed by version 1, as well as being able to print itself. Version 2 will allow a wider range of materials to be printed, including electrical conductors, so that the machine can make its own circuit boards and other electrical products.
If RepRap's successful, a number of changes may well happen in society. The principal one of them will be that we have the distribution of the manufacture of goods. At the moment, economies of scale mean that it's sensible for goods to be manufactured in factories and then to be shipped to individual people who wish to have those goods using a complicated transport system. If RepRap takes off and increases its abilities by evolution to manufacture more and more products, then people having these machines in their homes will mean there will no longer be a need, or no longer be such a big need, for factories to make the goods that they want. When they want something, it'll simply be a question of downloading it from the web in the way that they currently do with music or a film or anything else, and that downloaded file would then allow them to manufacture whatever object it was that they wanted in their own home. No transport involved except for the raw materials, which have to be transported anyway, of course, and thus we have short-circuited a large part of the conventional supply chain for material goods to individuals.
Then you can make one for your friend, and then there are 2 RepRaps, and then you can both make more RepRaps for more people, so it goes exponentially. There are 4, 8, 16, 32, and before you know it, everybody in the world's got, who wants one's got a RepRap, and nobody can hold the monopoly, so it keeps the cost down.
Chris DeBona, open source programs manager at Google, said, "Think of RepRap as a China on your desktop." And Sir James Dyson, inventor of the Cyclone bagless vacuum cleaner, said about RepRap, "Advanced fabrication technology that can copy itself is a truly remarkable concept with far-reaching implications." The objective of the RepRap project is to give away the designs for a machine that anyone can use to make many of the goods that we all currently have to buy. And anyone can also use their RepRap machine to make more RepRap machines for other people. The project aims to put a factory in every home, a factory that can make more factories.
So this is quite an old video. Since then, several generations of RepRap machines have been created both by the core team and by developers and enthusiasts around the world. The reason I wanted to show it is because it focuses on this idea of democratizing manufacturing, of enabling average citizens to actively participate in the building of their environment. And the fact that RepRap is open source is not an accident. It is core to the project's mission. In an email interview Aidan Boyer was kind enough to give me a few years ago, he stated this very clearly. He said, if world-changing and powerful technologies are controlled by a few people, then the few advance and the rest, to a greater or lesser extent, go hungry. The only way to avoid that was to give RepRap away for free and to ensure that future development stayed free. Now, microcontrollers in 3D printers played a critical part in the expansion of DIY hardware, but the story doesn't end there. It now includes satellites and drones, a variety of data collection tools and scientific instruments, agriculture and industrial machines, and even houses. So this is my house, and it's entirely open source. The exterior walls are made of compressed earth blocks, which we made with this open source machine by Open Source Ecology. This house was also designed to be hackable. So all the water and electrical lines are run inside channels along the perimeter of the floor and ceiling. Should we want to modify, repair, or add anything, all we have to do is remove the channel's cover. Just as important for us was modularity. All the wood components of the building, windows, interior walls, doors, roof, etc., are made of 4x8 modules that are first built on the ground and then assembled to form the structure, a little bit like large-scale Legos. So this allows us to build much faster and also enables replication and customization. Now, there are many interesting and creative house designs out there. For me, what I think makes this one special is the fact that it was designed online by groups of volunteers. Anyone who wanted to contribute could do so. And then it was built barn-raising style, also by volunteers through a series of workshops. So all in all, around 250 people contributed to the design and build of this house. That's something I'm quite proud of. So we learned so much the last couple of years with this modular crowd-based approach that we're now getting ready to launch a new project that will have at its core a crowdsourced library of modules that can be assembled to create a variety of building designs. Our goal is to make open source, it's to make housing more affordable, easier and more sustainable through an open source and collaborative approach. So now we come to another important question, which is why? Why is this happening now? Why are so many people interested in building their own technologies, in building their own environment? The short answer is deceptively simple, because we can. So in a very interesting book called Cognitive Surplus, Clay Shirky points out that as the quality of life and with it the amount of free time we have rose throughout the 20th century, most of us start spending more and more time watching TV. There are a few theories as why this is so, but the overall idea is that we took to watching TV because we preferred it over other more active ways of spending time. So as Clay Shirky puts it, the assumption is that we wanted to be passive participants more than we wanted other things. But then something strange happened in the last decade or two. Some people, not all, but quite a few, began choosing to dedicate part of their free time to contributing to Wikipedia and Linux, to making and sharing movies, music, books, recipes, articles, software. This seemed to clash with the idea that above all else we wanted to be passive consumers. Another challenge to this idea comes from a very well-established theory in the field of psychology called self-determination theory. So self-determination theory holds that all human beings have three basic human needs. The need to experience competence, to create, to cause change in our environment, to accomplish something. The need for relatedness, that is the need to feel connected to others, and the need for autonomy, to be masters of our own lives and our destiny. So what analysts like Shirky and Bankler propose is that the drive to be creative, to collaborate with others, to be causal agents, to produce not just consume, has always been there in every one of us. But the barriers to acting on those needs were simply too high. We watched TV because doing other things was just too hard. Once the barriers were lowered through enabling technology, supporting communities, and instant access to knowledge and know-how, we were able to act on the instinct to participate. More specifically, what enabled DIY hardware was a perfect storm caused by the combination of the internet with communities and fabrication tools. The internet and communities come hand in hand, of course. Communities built the internet and communities were formed on the internet. But as easy it is to these days send bits halfway across the world, we'll still need the ability to easily convert them into atoms, and that's hard. Back in 1999, Richard Stallman argued that because copying hardware is so hard, the question of whether we're allowed to do it is not vitally important. So the reasoning here is that if practical barriers to doing something are so high that only a few people can actually do it, then whether or not everyone else has the right to do it is not vitally important. Meaning, the right to do something is not enough, it also needs to be feasible and easy. So on this topic, I would like to share one of my favorite animation movies that depicts the past, present, and a possible future for manufacturing.
Happy birthday, son.
Happy birthday, son.
Glass cup design.
Yeah.
Download.
Share. Uploading. Save to disk.
Share, transfer in data.
Analyze. Share, transferring data.
Materials.
So 3D printers play a very important role in this ongoing transformation, mostly by their ability to capture the public's imagination, to render possible and feasible the idea of a future in which we are all co-creators. But in practice, they aren't yet the Star Trek replicators we hope they will one day become. They are still quite limited in terms of capabilities. But while we wait for the future to arrive, there are other ways in which citizens are getting access to manufacturing capabilities. Some examples include public factories, such as Shapeways and Pinocchio, where anyone can upload their designs and receive the manufactured objects in the mail a few days later. Another popular approach is for designers to take advantage of economies of scale by banding together. There are now quite a few online services that gather short runs of PCBs and then aggregate them into a single order. So this way, each designer gets only the small number of boards she needs, but the entire group takes advantage of the lower prices associated with large orders. And then there are services such as Alibaba and Maker's Row, which interface between creators of all scales, from a single person to a company, and factories in various locations around the world. So although we're still quite far from the future depicted on the full printed animation, we've come a long way in terms of making manufacturing more accessible. The future isn't quite here yet, but we can almost taste it. And now we come to the critical question. Why does it matter? Why should I care? How is this important? Well, open source matters, of course. It matters not just as a way to develop software or hardware, or as a way to enable a greater number of people to participate, create, and connect. It matters also to what kind of technologies we bring to life. It matters because technologies are not neutral. There is a school of thought that maintains that technologies are value neutral because they are driven by the pursuit of efficiency, by the ratio of inputs to outputs. But if we take a second to think about it, what is efficiency? Say you want to design a car. If you own an oil field, then the most efficient car will be likely powered by fossil fuel, right? On the other hand, if you don't own an oil field, but you live in a part of the world with plenty of sun, then a solar-powered vehicle makes more sense. So the idea here is that the shape of technologies depends on the context in which they are created, on the perspectives, needs, and assumptions of their creators. And in turn, the particular shape of each technology defines what can or cannot be done with it, which behaviors are encouraged, and which are made too difficult. Take, for example, the cases of the television and internet technologies. The television broadcasting system works mostly one way. For this reason, it puts the emphasis on listening, receiving, consuming. The internet, on the other hand, is multi-way. It allows speaking as well as listening, creating as well as consuming. It enables dialogue, participation, collaboration, diversity. So, taking this analogy a bit further, let's say that there are currently two ways to design technologies. One resembles the broadcast model of the television system, and the other the distributed model of the internet. And let's look at a couple examples that, in my opinion, embody these two approaches.
This is the new iPhone 6.
And this is the new iPhone 6 Plus.
They're the biggest iPhones ever made.
They're huge.
Yeah, but their size is just the beginning.
Even though they're huge.
Sure, but they could change the way you see the world.
Oh, that is so huge.
They could improve your health.
Huge!
They're the biggest, most powerful iPhones ever made. Huge! Stop it, please. Stop it. Thank you.
Huge.
Okay, so to me, what is clearly conveyed in this ad is the separation between producers and consumers. The message is simple. We are professionals, we know what we're doing, and we designed the perfect phone for you. Now buy it. Now, fortunately for us, there is a slightly different approach, and let's look at an example of another way to think about phone design.
Every day we throw away millions of electronic devices because they get old and become worn out. But usually it's only one of the components that causes the problem. The rest of the device works fine but is needlessly thrown away. Simply because electronic devices are not designed to last. This makes electronic waste one of the fastest growing waste streams in the world, and our phone is one of the biggest causes. So this is a new kind of phone. It's made of blocks. Detachable blocks. They are all connected to the base, and the base connects everything together. Electrical signals are transferred through the pins, and two small screws lock everything in place. So if, for instance, your phone is getting a little slow, you can just upgrade the block that affects the speed. Or if something breaks, you can easily replace it with a new one, or update it with the latest version. Another great thing about this is, you can customize your phone. So let's say this is your phone, and you do everything in the cloud. Why not replace your storage block for a bigger battery block? If you're like this guy and love to take pictures, why not upgrade your camera? Or if you don't care about any of this stuff, you can keep it simple and get a bigger speaker. You can choose the blocks you want, support the brands you like, or even develop your own blocks. PhoneBlocks is built on an open platform where companies work together to create the best phone in the world. To set up this platform, we need to get the right companies and the right people involved. They will only get started if there is a lot of interest in a phone worth keeping. So this is the plan. To show them there is an interest for this phone, we need your voice. You can donate your social reach on the website. We gather as much people as possible. On the 29th of October, we send out the blast, all at the same time. Spreading all your voices to show the world there is a need for a phone worth keeping. The more people involved, the bigger the impact. Please visit phoneblocks.com to raise your voice and spread the word. PhoneBlocks, a phone worth keeping.
Okay, so in projects such as PhoneBlocks, rather than designers assuming that they know what we want and assuming that we all want the same thing, the choice is transferred to the users, to the people who actually use the devices. So in this approach, we are all co-creators. To make that possible, distributed technologies need to be pliable and flexible, so they can be individually transformed and collectively shaped. Now, technologies that are individually transformable and collectively shaped aren't just what someone else thinks we want, they are what we want. And on a broader scale, a distributed approach may also mean that we'll develop technologies that reflect the diversity of the world, rather than just the perspective of a few manufacturers of hardware. This may mean more sustainable, affordable, and appropriate technologies, I hope. And because technologies play such a vital role in our lives, what they enable, what they encourage, greatly contributes to defining what kind of world we live in. So to conclude, I just wanted to kind of stress this idea, that this belief that I have, that open source is bigger than making software and hardware. It's an enabler. It allows us to fulfill fundamental human needs for autonomy and participation and collaboration. It allows us to become better human beings and to build the world we actually want to build. So thank you very much. I think we have some time for questions, Kathy.
A round of applause for Catarina.
Thank you.
What an absolutely magnificent keynote. How using open source technologies, 3D fabrication, scattered with diversity, more equity, and sustainability can help us change the world. An amazing keynote. Incredibly inspiring. I do have some questions. The first question is from Daniel Axtens. And Catarina, when you're building with your open source house, how did you manage regulatory compliance?
Yes, that is a very pertinent question, and usually the first one that comes up. In practice, I am lucky enough to be located in a part of the world where there are no building codes. We can... So that is one way of approaching it, is to escape the building codes, but a few of the modules, we've been working on this for a couple years, not seriously, not as a full-time project. I'm only beginning now to switch my full attention to it. But we've worked with architects and builders before, and some of the modules are already up to code. And what I hope is, again, to harness this idea of open source and community, and then work with a bigger group to bring the rest of the modules up to code, to international code, and eventually have people who are interested in building houses in different regions of the world also make derivatives and fork whatever they need to fork so they can create versions that adapt to the codes in their own area. But it is definitely one of the big challenges, and that's true for all open source, which is how do we interface with regulations. If anyone has any ideas, please come find me.
Excellent answer, thank you. I have a question of my own. As we take the power away from the elite few, from the manufacturers, and we put power in the hands of the people, what incentive do manufacturers have to get on board with this movement? How do we make it attractive for them as well?
Okay. So one thing I didn't mention today for the sake of brevity is that just like open source software is highly compatible with business, so is open source hardware. So basically we just find business models that are not dependent on intellectual property. There are quite a few open source companies. One of the most well-known is SparkFun. It's been around for 10 years, has around 150 employees, and all their work is open source, and they're doing very well. So there is that idea that you do not need to stop doing what you're doing, you just need to shift it a little bit. And you can still have your business and still prosper. So I think it's mostly about us setting up examples of businesses. It's like entrepreneurship is fundamental to make this happen, so that those older manufacturers can say, okay, well, this works, I'll give it a try.
And we make them all part of the ecosystem.
Yes, exactly.
Catarina, I can't express what an incredible privilege, what an honour it's been to have you in Geelong, in Australia, and how delighted we are that you've been able to inspire us this morning. Everyone, Catarina Mota.
Thank you so much. I mean, the pleasure is all mine. Thank you, Kathy. Thank you. Oh, sorry. Much. This is quite a pleasure. Thank you.
So we now have morning tea in the Costa Hall foyer, and followed by the main conference schedule. Thanks, everyone.